So before we get into factoring trinomials with a greater than 1, I would suggest watching factoring trinomials when a is equal to 1, because we're going to be using a lot of the same principles and the same ideas from factoring in the previous video as we are in this one, and it'll be kind of difficult to catch on. But either way, hopefully it'll be an easy thing to grasp. So this first page, we've got our parent function that we always go off of, a x squared plus bx plus c. And I've got a few steps for us that we'll keep on the side of the page, but just for us to review real quick, we've got a GCF check. That is always our first order of business. And the second one is multiply our a and c. You'll see, you will see how that kind of plays in as we do an example. And the product of a and c will be our new c. Again, that'll make sense in a second. And b's purpose will stay the same. And then lastly, we're going to group and then GCF check. A lot of that may not mean anything right now, but it will here in a second. So let's split screen this and get on to an example. Okay, first example, 12x squared minus 13x minus 14. I'm trying to do some somewhat difficult problems just so we will be able to tackle the difficult ones and the easy ones will be easy. So first off, we want to do step 1, a GCF check. Do any of these have a value in common? And you should be saying no, they don't. So okay, we checked our GCF. That's the ugliest check mark ever, but don't judge me. So we checked our GCF. Now we have to multiply a times c. So 12 times a negative 14. Okay, so that should be 168. That's negative, of course. Don't want to forget that. Okay, so that becomes our new c. And as we know from class and from the previous video, that c is the value we are multiplying to. So our new c is 168. So we are now multiplying to this number. And b stays the same. So we are still adding to this number here, negative 13. Thanks, Windows. We want to bring down these two terms. So we can just go ahead and bring down our first term and our last term, because those are going to be consistent. All right, now we have to find two numbers that are going to multiply to negative 168, but then add to negative 13. Okay, so it might take a second for us to really think of those, but with some help of a calculator and the thing stronger than a calculator, your brain, of course, you would know that we could we could separate this into 8x and negative 21x. And you can check me on this. 8 times negative 21 would be negative 168. And then positive 8 minus 21 would give me negative 13. So I want them to multiply. I want them to multiply to c and add to b. So now, we have not broken equality. We talked about this in class. We have maintained equality because this top equation, the top polynomial, is the same as this bottom polynomial, just written in a different form. So for instance, a real-life example would be the ingredients of a cake. They don't change just because you mix them together. You're still using the ingredients that you are. They're just being mixed into a bowl and spun together and heated up in an oven. The ingredients don't change, just the look of it changes. So same thing with a polynomial. We're just changing the look of it, but it remains equal. Okay, so we have multiplied a and c. That's a better check mark. And we have found a new c. So step 2 is checked off. B can be checked off as well. 13 remains the same. And we found 8 and negative 21. So let's move on to the next part where we group them. So I'm just going to take these first two terms and they're going to become a group. 12x squared plus 8x. Alright, and then this group is going to become negative 21x minus 14. Alright, this grouping step is kind of a big one. So it's an all-encompassing word there. But what we want to do is find the GCF of each one of these. So in common, these two terms have in common an x as well as 4. So they're both divisible by 4 and they're both divisible by x. This can become now 3x because 12 divided by 4 is 3 and x squared divided by x is just x, so that's what we're left with. And then 8x divided by 4x is just 2. And over here we have a negative 7 in common. And they do not have an x, so it's just a negative 7. And we are left with a positive 3x and a positive 2. Okay, if you're ever unsure of that you got these right, especially the positive and negative signs, you can always multiply back in. So negative 7 times 3x, well, that's negative 21x, so you know you're good. And negative 7 times a positive 2 would give me negative 14. So we just do a quick check to make sure we're on the right path. Okay, so if you notice, my insides are the same, 3x plus 2 and 3x plus 2. Okay, so we're going to combine those to become 3x plus 2. And we're going to combine the outsides as well. 4x and negative 7 are going to become a group as well. Okay, and mathematically we can do that because we are factoring out a 3x plus 2 out of both of this first term and the second term. So I know we talk about grouping the insides and grouping the outsides, but mathematically it's because we are factoring a 3x plus 2 out of both of them. So now our final check, we always want to do a GCF check. Is there a GCF between these two numbers? No. GCF between these two numbers? No. So you know your answer must be complete and you are finished, and that is the answer. Okay, another problem, a lot more difficult, but still one easy to tackle if we just follow our steps. So let's bring down 24x squared. We'll bring down negative 12. All right, and we can, we can then multiply a and c. So it's going to be a big number, 24 times negative 12. And with your calculator you should find that this is negative 288. Okay, so this seems extremely scary that we have to find a number that multiplies to negative 288 but then also adds to 68. Okay, so let's just go through the simple ones, and they're probably going to be some pretty large numbers. So we know some numbers that go into, well, here's what I like to do is first focus on the main part of this number, 280. Some numbers that go into 280, 70 goes into 280. It goes in 4 times. Okay, so if 70 goes in 4 times, or 4 goes in 70 times, so 4 times 70 would give me 280. Well, I know I can just add 2 more groups of 4 to get to 288. So 4 times 72 would equal 280. Okay, so it appears that I found something. Whoops, not 280, 288. I want to do 288. 4 times 72 equals 288. And I've now found something that will multiply to 288, but will also, if we notice, will add to 68. If I were to make this 4 a negative, well, 72 and negative 4 makes 68. So I have just found my two numbers, and I'm going to put 72x over here and negative 4x over here. That's a positive 72x. Alright, so let's get rid of all that math. Hopefully you understood what I was doing there. Alright, so now we've got our two numbers. It makes sense. We have maintained equality from this step, from this first step down to the second step. Now we can move on to grouping. Alright, so we've got 24x squared minus 4x and 72x minus 12. We're going to find the GCF in this first one. It looks like it's 4x. Okay, and so a 6x is left over. A minus 1 is left over from the 4x. And then over here I'm going to factor out a 12. And what's left is 6x minus 1. Okay, we should be excited because our insides again are the same, which means we've been doing things right. So now let's factor out the inside, or group the insides. So we have 6x minus 1, and then we're going to group the outsides to become 4x plus 12. Okay, and because at the beginning we weren't totally sure, at least I wasn't totally sure, and not sure that we could immediately recognize that there's a GCF in all of these. But that's okay. Even if we miss this first GCF check, down here at the bottom, the GCF check will work itself out. So we want to look here. Is there anything in common between 6x and negative 1? The answer is no. But here, there is a GCF. They both have a 4. So we're going to pull out that 4. All right, and so we're left with our final answer is actually just going to have that 4 out front. And it doesn't matter what order we put these in, because multiplication is commutative. All right, our final answer will be 4 times 6 minus 1 times x plus 3. And we know that we are done because there's no more GCF that can come out of that. So we are finished.